let's go back over to our Solution Explorer now and select our Screens folder, and then we will right-click on that and add a new class. And this class is just going to be called Debug. And this will be our debug screen. With this screen we can display our FPS, our frames per second, and also kind of keep track of what other screens are active and which ones have focus. It's just kind of nice to have. So what we will do is come back to the top, and just like we did in the test screen, we're going to inherit the base screen class. And then again we will set up some local properties for this new screen. So we'll say public screens as string. This is just going to be a list, very basic formatted list of the names of the screens that we have active in our screen manager. Then we can do public focus screen as string to keep track of the focused screen. And next we'll set some variables to monitor our frames per second. So do private FPS as an integer, and private FPS counter also as an integer. And then we will create an FPS timer. Say private FPS timer as a double. Whenever whenever we are referencing the game time, we're going to be using a double type. And finally we'll do private FPS text as a string to output it to our screen. And let's also add a private BG rectangle. So what this is going to do is just store a rectangle value for the background of our screen that we're creating here, our debug screen. Excuse me. Unlike the test screen that we created, we don't want our debug screen to be taking over the whole screen. We just want a little window that we can monitor and turn on and off as we choose. So we're going to say as a rectangle here. And let's also monitor, since we don't actually have an input class set up yet, we're going to monitor our key down events. So we're going to say private key down as a boolean equals false. And because we're not actually managing our input, it's gonna, every time it runs through an update cycle, it's going to be pulling the keys. So you don't want to have, as fast as XNA is running through these cycles, you could, be having hundreds of these key events per second. So, so like our other screens, we're going to create a new sub. So we'll say public sub new to create a new instance of this class. The name will be debug, and the state is going to be hidden in this case, because we don't want the debug screen to always be visible. We want to be able to kind of turn it on and off as we will. Grab focus is going to be set to false, because we really don't want our input, or I'm sorry, our debug screen stealing input from our other screens that are active. Next up, we will be handling input for this screen. We'll say public overrides, because we're going to be overriding the handle input from the base screen that it's inheriting from. We'll say sub handle input, go ahead and get rid of that. All right, so I'm going to say this will be temporary until we create an input class. Whoops. We'll say if input.keyboard.getState is key down, then we have to tell it what key we're monitoring for, so we'll just say F1, keys F1, and key down, that's our variable up above, equals false. Then go ahead and set the key down value equals true. And that way, while we're holding the key down, you know, even if it's very brief, it could launch numerous times. This will lock it into a single event. So as soon as that key goes down, it sets the key down to true, so this statement here is no longer true, and it'll stop looking for that event. So I'll say if state equals screen state active, then the state will be set to hidden. Okay, so if the screen is active, then it will be set to hidden. Else if the state equals hidden, we'll set it to active. So what this is doing is we're going to say when we press the F1 key, if the screen is actually active and visible, then we want to hide it. If it's not visible, then we want to show it. So that's all we're doing there. Pretty simple. And next up, we're going to say if input.keyboard.getState.isKeyUp. Going to monitor for when we take our finger off that key. Say F1 again. And key down equals true. Then just set our key down state to false. Okay? So this basically just frees up the input. So it's ready to accept another. That sort of waits for you instead of continuously launching that. And kind of resets the value when we're done. Okay, now we have to go on down to create an update sub. So again, we're going to say public overrides sub update. All right, you can leave that my base.update if you want. So anything beneath it continues to get updated. Let's see if screens dot length, and we're looking at our the string that we created up above. So now we're just gonna format that screen to display what text we want it to. So we're gonna say if the length is greater than 0, then screens equals screens dot substring, to grab a portion of that string at 0 as the start index, to screens dot length -2. So we're just formatting that string here. If the length is greater than 0, then we're going to set that text to be substring of that text to the length -2. Hopefully that will become more clear as we go through this. And then we're going to create a couple of dimension variables here. I'm going to do text width as integer equals 0. And then text height as integer equals 0 again. So we're going to store the width and height of our text in that string. Then we're going to say if fonts, remember that's a link to our fonts global class over here, dot Arial8 dot measure string. This is a sprite font feature. You can actually measure the length and height of your strings that you're passing through it. So we'll say the text that we want to measure is screens dot x, being the width, is greater than text width. Sorry, that's txt width was our variable. Then text width equals fonts dot Arial8 dot measure string screens dot x. Okay. So as you see, we come through the first time it runs through, it's going to see that this text width is 0, and so it's going to, this is going to be true. The width of the string is going to be greater than 0, so it's going to set a new width to this variable based upon the width of this string. So when that string changes, every time it changes, it's going to set a new width, and we can track that width of that string. Alright, so we have to do the exact same thing also for the height. I'm sorry, for, let's see, the focus screen, or the name. So we'll say if fonts Arial8 dot measure string. This time we don't want just the width of the entire string's screen. We want the focus screen, the screen that's focused. Dot x is greater than, again, the text width. Then we will set that text width equals fonts dot Arial8 dot measure string focused screen, and you might have seen my error up here, focus screen. Focus screen. Come down here and grab the X value for the width. Okay, so we're setting two different things here, sort of. We're setting this the text width to the screens, the list of screens width, and then we're setting that to the focus screens width. Then we go to txt height equals fonts dot Verdana. No, I'm sorry. That is not what I wanted. Arial8 dot measure string. I think my brain's getting tired here. And we want to measure the height of the FPS text. String formatting can be fun. Tonight it's not fun. All right. So the reason we're capturing these measurements is so we can actually set the size of our screen using that background rectangle. We're actually setting the visible size of the screen. So we're going to say BG rectangle is a new rectangle. And we're going to be drawing it at the top left corner of the screen again. And we are going to draw the size of it as txt width. And we're going to add, you know, a 20 pixel margin on that. And by the size of txt height, also with a 20 pixel margin. So what that should give us is a new rectangle that is roughly the same size as our string that we set here up in the top, plus 20 pixels. So it kind of creates a dynamically sized background for our new screen. Because again, we do not want this taking up our whole screen. We just want it to take up a little portion of the screen, but it has to grow and shrink according to the size of the text within it. If there's a lot of text in it, we want it to grow so we can see the whole thing, or that text actually stays inside of that rectangle. So we're sort of forcing that here. I know it sounds it's kind of hard to understand here, but you'll see it. You'll kind of understand it when you see it in action. I'm going to go ahead and save my project here.